You spend your day in the Microsoft 365 admin portal, clicking through dashboards, managing users, adjusting policies, and it feels like you are in control, but you are not. The portal is just a convenience layer. It was built for administrators who manage dozens of users, not thousands. It was designed so someone could configure one setting, one time, for one person. It is perfect for that, but in reality, it is a bottleneck masquerading as a control center. Most organizations operate at about 10% of their actual automation capacity. They have the capability to scale across thousands of users, devices, and workloads automatically. Instead, they are clicking, waiting, clicking again, and they are calling that administration. But here is the problem. Azure AD Graph is retiring June 30th, 2025. The Graph CLI is retiring August 28th, 2026. Microsoft is not giving you a choice. They are consolidating every control surface onto Microsoft Graph, and PowerShell is becoming the only viable interface at scale. This episode is not about learning an API. It is about understanding enterprise throughput. It is about seeing what the portal hides. By the time we are done, you will understand why the future of Microsoft 365 administration belongs to those who think in systems, not clicks. The scaling flaw. Why portals fail at enterprise scale. The portal was designed for individual configuration. Create a user, assign a license, add them to a group. Done, one action at a time, one person at a time. That model works until it does not. The moment you need to do something at scale, across hundreds or thousands of resources, the portal breaks. Not technically, it keeps working, but operationally it falls apart. Because in reality, manual clicks do not scale. They compound. Every decision you make in the portal cascades into operational debt you cannot see. A user added manually to the wrong group. A team site provisioned without proper retention settings. A permission granted that should have been restricted. These are not one-time fixes. They are problems that snowball. Let me show you what scale actually looks like. A global manufacturer needed to manage 20,000 tablets across factory floors. They had two paths. Path 1 was to provision each device manually through the Intune portal. That is 20,000 clicks, thousands of hours, errors everywhere. Path 2 was to automate via Graph APIs, zero-touch enrollment, automatic policy assignment, configuration validation. The same outcome. 20,000 fully provisioned compliant devices, but in a fraction of the time with zero human error. But here is what matters more than the time. Context. When you work through the portal, you see one user, one device, one setting at a time. You get no view of patterns, no visibility into what is misconfigured across the entire organization. You cannot answer questions like, how many sites do we have that are oversharing content? Or, which applications have excessive permissions? Or, what is our true license utilization? The portal hides these questions. It forces you to manually audit, manually investigate, and manually check each resource. Permission audits that should take 2 days, take 3 weeks, because you are clicking through the interface one item at a time. With Graph, those same audits run in hours, automated, continuous, visible. And then there is the skill gap. By 2027, and this is already happening, portal-only administrators will not be able to compete. They cannot architect solutions, they cannot scale, they cannot see the data their systems actually contain. They are operators of a GUI, not architects of systems. Organizations are already recognizing this. They are forming automation teams. They are treating Graph and PowerShell as core competencies. The gap between portal clickers and graph-thinking architects is widening every quarter. The real cost of the portal is not time. It is the decisions you cannot make, the risks you cannot see, the optimization you cannot do because you lack visibility into the actual state of your organization. Understanding this flaw is the first step. Now let us talk about what actually works. What Microsoft Graph actually is beyond the definition. Stop thinking of Microsoft Graph as an API. That framing is technically accurate, but strategically useless. Calling Graph an API is like calling the internet a bunch of cables. It's true, but it completely misses the point. Graph is the operating system for Microsoft 365. It is the single layer through which every user, file, meeting, and security alert in your organization is managed. It consolidates over 700 endpoints across identity, collaboration, and security into one consistent interface. One data model, one permission system, one place where your entire organizational graph lives. And here is the thing most admins don't realize. You are already using Graph. Every time you open the Microsoft 365 Admin Center and click a button, the portal makes a Graph call in the background. The Admin Center is just a wrapper around Graph. The Intune portal is a wrapper around Graph. Teams, Exchange, SharePoint. All of them are just user interfaces built on top of the same underlying system you could be calling directly. When you click a button to assign a license, Graph executes that action. When you search for a user and their details appear on screen, Graph fetches that data. You are already in the system. The portal is just putting a slower, less powerful interface between you and the actual work. The question isn't whether you use Graph. You already do. The question is whether you use it intentionally, at scale, with full control, or accidentally, one click at a time, through a GUI designed for single operations. Now you can interact with Graph directly in two ways: REST endpoints and the PowerShell SDK. They call the same service, they hit the same endpoints, they authenticate through the same identity model. The SDK just wraps those REST calls in PowerShell CMDlets, so you don't have to build HTTP requests by hand. The SDK is faster for common operations, but raw REST gives you more control when the SDK hasn't caught up with a new feature. That leads to the beta versus v1.0 distinction. Graph runs two tracks. The v1.0 endpoint is stable and production ready. The beta endpoint is where new capabilities appear first, often months before they reach v1.0. The Intune and Teams product groups build against beta because that is where the full feature set lives. Most serious automation work happens in beta. You just have to understand that beta endpoints can change without notice. Why is Microsoft forcing everything through Graph? Because they are building their entire future on it. Copilot uses Graph to retrieve your documents and emails. AI agents use Graph to take actions in your tenant. The entire agentic automation stack. Agent 365 Copilot Studio autonomous workflows. All of it runs on Graph as the foundational layer. Every capability Microsoft ships going forward will land in Graph first. Legacy APIs are being retired because they cannot support this future. AWS is going, Azure AD Graph went, the MS Online module is gone. The consolidation isn't optional, Graph is the only viable path forward. Now that you understand what Graph is, we need to talk about the permission model that makes it work. Authentication, permissions, and the principle of least privilege. Every Graph call starts with identity. Before Graph reads a user or modifies a policy, it needs to know who is asking and what they are allowed to do. If you get this wrong, you either cannot automate anything, or you create a security hole large enough to compromise the entire tenant. There are two permission models, delegated permissions and application permissions. They sound similar. They are fundamentally different. Delegated permissions mean the application acts on behalf of a signed-in user. The user logs in, consents to the app, and the app can do whatever that user is allowed to do. Nothing more. If the user cannot read a certain mailbox, neither can the app. The user's existing rights form a ceiling. This model makes sense for interactive tools, something a help desk admin runs while authenticated as themselves. Application permissions work differently. There is no signed-in user. The application authenticates as a service principal, a non-human identity registered in Entra ID, and it acts on its own authority. Application permissions are tenant-wide by default. If you grant an app mail, read as an application permission, it can read every mailbox in the organization, every single one, without any user context limiting it. This is the model you use for background automation, scheduled jobs, runbooks, and anything that runs without a human present. That distinction matters because application permissions are where most organizations get into trouble. They grant broad scopes during initial setup, forget about them, and then wonder why a compromised service principal can access everything. The Microsoft Graph Permissions reference is the document that maps every action to every required scope. Most admins have never opened it. That is a problem. The permissions reference isn't just documentation, it is your security architecture. It tells you exactly which scope grants which access and whether admin consent is required. Read it, bookmark it, use it every time you build something new. Least privilege isn't optional, it is the structural difference between a secure tenant and a compromised one. A service principal with directory, read, write, all, and mail. Read, write is effectively a super admin robot if its credentials are stolen through a leaked client secret or a misconfigured pipeline. The attacker inherits everything that principal can do. And if you have been generous with permissions, that is everything. The environment is getting more restrictive. Starting in mid-2026, Microsoft is changing default consent behavior for exchange-related graph scopes. New apps requesting exchange permissions will require explicit admin consent by default. Apps that previously relied on user self-consent will start failing unless they have been explicitly approved. Organizations that haven't reviewed their app registrations will start seeing 403 errors in production. So when do you audit? You should audit monthly for high-risk applications. Anything with directory write access or mail access, you should audit quarterly for lower privilege apps and routine reviews. And you must audit on an event-driven basis whenever a new app is registered. New app registrations and consent events should trigger an immediate review, not get buried in a quarterly batch. And here's the connection most organizations miss until it is too late. Copilot cannot be deployed safely until permission hygiene is restored. Copilot inherits the permissions of the signed-in user. If users have access to content they should not see, because permissions were granted broadly and never reviewed, Copilot will surface that content instantly. The permission debt you have been accumulating for years becomes an active AI exposure risk the moment you deploy Copilot. That is not hypothetical. That is the reality organizations are discovering right now during readiness assessments. The permission model is where your security architecture either holds or breaks. Build it with least privilege from the start. Review it on a cadence. And treat every broad permission grant as a risk you have consciously accepted, not a convenience you have forgotten about. With authentication and permissions understood, we can move to the real work, what you actually do with Graph. The user lifecycle, from joiner to leaver. Identity lifecycle is where most organizations bleed time. They don't even know they're losing it. Someone gets hired, it gets a ticket. A human opens the admin center, they create the account, They assign a license, they add the person to groups, they set up the mailbox, they provision the team's workspace, they grant SharePoint access. If it goes smoothly, it takes 30 minutes. If it doesn't, it takes an hour. Now multiply that by 50 hires a month, or 100. You aren't running an IT team anymore. You're running a manual data entry operation. Graph PowerShell eliminates that entirely. A single script can create a user in Entra ID and assign the right license based on their department in seconds. That same script adds them to security groups, provisions their team's workspace, and configures their mailbox without a human ever clicking a button. One execution. Consistent output every time. The script that runs for hire number 1 runs exactly the same for hire number 10,000. But the script has to be built right, and that means you need to understand the idempotent principle before you write a single line. Idempotency means the script checks before it creates. Before it adds someone to a group, it verifies they aren't already a member. Before it assigns a license, it confirms one isn't already there. Before it creates a mailbox, it checks if one exists. The pattern is always the same. You use getMinch first to verify the state, then you use newMinch or updateMinch only if the action is actually needed. Why does this matter? Because automation runs repeatedly. Scheduled jobs fire nightly. Pipelines trigger on events. Without idempotency, a script that runs twice creates 2 accounts, it assigns 2 licenses, it adds the user to the same group multiple times. What was meant to be automation becomes a cleanup project. Idempotent scripts are safe to run as many times as you need. That's what makes scheduled automation viable. Then there's the mover scenario. Someone transfers between departments. Their access needs to change. Old groups get removed, new ones get added. The manager field needs an update in the directory. In the portal, someone has to do all of this manually. They have to hope they don't miss a step. They have to hope the ticket is accurate. With Graph, you read the change from your HR system. You validate it against the current state. You execute the delta. Only what change gets touched. Everything else stays exactly as it is. The lever scenario is where most organizations have their biggest exposure. Employee termination is not a suggestion. Access needs to be revoked immediately, not at the end of the day. Not when IT gets around to the ticket, immediately. Graph automation closes that gap. A termination trigger from HR fires a runbook. It disables the account. It revokes active sessions using revoke sign-in sessions. It strips licenses and preserves mailbox content under litigation hold. All of this happens before the person has even left the building. There is one technical detail you need to know. Teams creation is asynchronous. When you call new MG team, Graph returns a 202 accepted response. It does not return a 200 OK. The team isn't ready yet. Your script has to capture the operation URI from that response. Then it has to poll the team's async operation endpoint until the status says succeeded. If you skip this, you'll try to add members or channels to a team that doesn't exist yet, the script will fail. Handle it correctly, and your provisioning flow becomes fully automated and reliable. Entra ID governance takes this further with lifecycle workflows. These are pre-built templates that trigger on identity events. They use Graph as their execution backbone. Joiner, mover, leaver, pre-configured, auditable, consistent. User lifecycle is foundational, but the real power emerges when you scale across the entire tenant. Teams, SharePoint, and OneDrive at scale. The collaboration layer. Teams and SharePoint aren't separate products that Graph happens to touch. They are fully exposed through Graph, just like users and licenses. Every site, every document library, every permission assignment, it's all reachable, it's all readable, it's all modifiable through the same API. That means the same automation discipline applies. And it means the same sprawl problems exist, usually at a much larger scale. Here's what happens in most organizations without governance. A team is created for a project. The project ends. The team stays. Another site is provisioned for a department initiative. The initiative wraps up. The site stays. Multiply this across 3 years and 1,000 employees. Now you have thousands of abandoned Teams workspaces. You have orphaned SharePoint sites. You have OneDrive libraries full of content nobody is managing. Microsoft research suggests automated site cleanup typically removes 20 to 30% of inactive sites in unmanaged tenants. That isn't a rounding error. That's a governance failure hiding in plain sight. Graph lets you fix this systematically. You can query every site in the tenant. You can pull activity metrics. You can identify when each site was last used. You flag anything inactive beyond your threshold. Then you notify owners automatically. You wait for a response. You archive or delete based on policy. The entire lifecycle runs without a human ever touching the portal. Site provisioning automation solves the other side of the problem. Instead of letting anyone create a Teams workspace with any name, you route it through a script. Naming conventions are enforced. Retention policies are applied at creation. Sensitivity labels are assigned based on the department. External sharing is either enabled or blocked based on the classification. Every site that gets created is compliant from the first second it exists. Now, SharePoint's structure is something most admins underestimate. Everything in SharePoint is ID-based. It isn't name-based, it isn't path-based, it is ID-based. If you want to interact with a document library, you need the site ID, then you need the drive ID, then you need item IDs for folders and files. The display names you see in the browser don't exist at the API layer. Those are just labels over a hierarchy of GUIDs. This trips up administrators who try to write automation using folder paths. When the path changes, the script breaks. When you use IDs, the script is stable. It doesn't matter if the site gets renamed or reorganized. The good news is that Graph makes ID discovery straightforward. You query a site by the URL fragment to get its site ID. Then you traverse the drives and items from there. Once you have that ID hierarchy, automation is reliable and fast. External sharing audits deserve their own focus. The portal shows you sharing settings in aggregate. Graph shows you the actual links. It shows you which documents have public links. It shows you which sites have anonymous access enabled. It shows you which users have granted access to external parties that the organization didn't intend. This data is there. The portal just doesn't surface it in a way you can use at scale. A graph query across the tenant exposes every external sharing configuration in a single export. It turns a review that would take weeks of manual checking into a single task. There is one critical constraint if you're building Copilot connectors. It's the 500 KB response limit. Copilot Studio connectors will fail if a single graph response exceeds about 500 KB. This isn't negotiable. If you're pulling file metadata or document lists and your result set is large, you need pagination, you need server-side filtering, you need selective field retrieval. Use select to return only the properties you actually need. Use filter to narrow the result set before it reaches you. For anything high volume, consider a middleware layer that aggregates and compresses the data before handing it to Copilot. Sensitivity labels and DLP policies are also enforced through Graph. They aren't just visible. You aren't just reading configurations. You can apply them. You can modify them. You can verify coverage across the tenant programmatically. That is the difference between governance as a report and governance as an enforcement mechanism. Collaboration is where most of the organizational data lives. Now let's talk about the security layer that protects it. The security imperative. Graph as your threat detection layer. Security teams have a visibility problem. They're watching firewalls, monitoring endpoint alerts, reviewing Defender dashboards, and they're completely missing what's happening at the application layer inside their Microsoft 365 tenant. Service principals authenticating at 3 in the morning. Apps with mail read permissions querying hundreds of mailboxes. Configuration changes happening through automation that nobody documented. All of it is invisible unless you know where to look. Graph is where you look. The Microsoft Graph Security API consolidates alerts from Defender for Endpoint, Defender for Cloud Apps, and Defender for Identity into a single normalized endpoint. It pulls in signals from Sentinel and third-party providers too. One query, unified alert schema. Every security signal your tenant generates is accessible programmatically. You don't have to jump between 5 separate dashboards that don't talk to each other. Security teams running graph-driven playbooks can correlate a risky sign-in alert with the app permissions that principal holds, the resources it recently accessed, and the conditional access policies that should have blocked it. This happens in a single automated investigation, not a manual cross-tool chase. Service principal activity logging is where the real hidden risk lives. Most organizations have dozens, sometimes hundreds, of registered applications in their Entra ID tenant. Some were created by developers years ago, others came in with third-party integrations, and many have owners who have since left the organization. Every one of these principals authenticates against Graph. They query data. They take actions. And most security teams have no visibility into what they're actually doing. Graph activity logs changed that. They reached general availability in April of 2024, and they provide something Azure AD Graph never could. They give you HTTP-level visibility into what applications are doing inside the tenant. You see which endpoints they're calling. You see how often. You see what data they're reading. If a service principal suddenly starts querying the user's endpoint for every account in the directory, that shows up. If an app that normally reads calendar data starts accessing mail, that pattern is visible. This is the kind of behavioral baseline that makes anomaly detection possible, because without it, you're flying blind on application activity. Conditional access deserves more attention than it typically gets in automation discussions. These policies aren't just security configurations. They are the enforcement layer that determines whether an authentication succeeds or fails. Understanding them means understanding the actual security posture of the tenant, not just the stated policy. Graph exposes every conditional access policy, every named location, every compliance requirement, and every exclusion. A systematic review via Graph often surfaces configurations that haven't been touched in years. You find exclusions granted for a pilot that never got cleaned up, legacy authentication still permitted for an app that supports modern auth, compliant device requirements not applied to privileged accounts. MFA coverage audits and risky sign-in detection are also graph-driven operations. You can query authentication methods across every user in the tenant to identify who has MFA registered and what methods they're using. This allows you to flag accounts with no strong authentication at all. When you cross-reference that against risky sign-in data from identity protection, you have a prioritized remediation list. It's an actual data set, not a gut feeling about where the exposure is. But here's the thing about the attacker's perspective. Adversaries actively prefer deprecated APIs because they lack modern logging. Before its retirement, Azure AD Graph generated sign-in events but not API-level activity records. Security teams could see that a token was issued for Azure AD Graph, but they couldn't see what operations were performed with it. Microsoft has been explicit about this. They expected attackers to keep using Azure AD Graph with compromised credentials precisely because the activity was hard to detect. Moving to Graph isn't just a technical migration. It improves your detection posture because you gain logs that simply didn't exist before. Monthly permission reviews for high-risk applications aren't a best practice recommendation. They are a non-negotiable control. An overprivileged app with a leaked credential is an attacker with tenant-wide access. Review cadence is your last structural defense. Security is foundational, but it's not the only reason to master Graph. Governance, compliance, and the audit trail. Governance has a reputation problem. Most organizations treat it as a restriction layer. They see it as a set of policies designed to slow people down and generate compliance paperwork. That framing is exactly backwards. Governance isn't about restrictions. It's about visibility and consistent enforcement. It's the difference between knowing the state of your tenant and hoping it's fine. The organizations that get governance right aren't the ones with the longest policy documents. They are the ones where the policies are actually enforced, automatically, continuously, and with an audit trail that proves it. Sensitivity labels and retention policies are where that enforcement starts. A sensitivity label isn't just a color-coded badge on a document, it's a control mechanism. Label a file as confidential and Graph enforces that classification downstream. DLP policies restrict where that content can be shared, while retention policies determine how long it stays and when it gets deleted. If legal proceedings require it, e-discovery holds will override that deletion. All of these controls are connected. All of them are configurable and auditable through Graph. Without that programmatic layer, you're applying policies manually and inconsistently. You have no reliable way to verify coverage across thousands of documents and sites. E-discovery is where governance failures become expensive. A legal hold placed on the wrong mailbox. A retention policy that expired before an investigation began. Content deleted because lifecycle management wasn't configured correctly. These aren't hypothetical failures. They are the kind of events that result in sanctions and missed discovery obligations. They lead to settlements that dwarf any IT budget. Graph integration with Microsoft Purview means you can verify legal hold coverage programmatically. You can confirm retention policy application across workloads and generate evidence that your information architecture is defensible. That's not a compliance checkbox, that's litigation readiness. Audit preparation is where Graph's ROI becomes financially concrete. Manual audit prep typically takes weeks. You have to pull access logs, document permission states, and export configuration records across different workloads. Teams are assigned to gather evidence and cross-reference records to produce reports that are already partially out of date by the time the auditor arrives. Graph automation compresses that timeline significantly. The same data collection that takes a team 3 weeks manually runs in hours via scripted queries. The evidence is current, the reports are generated programmatically, and the audit package exists as a repeatable artifact. Not a one-time scramble, Purview integration extends this further. Graph exposes compliance policies, communication configurations, insider risk signals, and data lifecycle policies through the same consistent API surface. You aren't managing compliance across 5 separate admin portals. You're managing it through one data model with consistent authentication and consistent programmatic control. Data residency and cross-border transfer controls matter more than most organizations realize until they're in the middle of a regulatory inquiry. Where data is stored, how it moves, and what controls govern that movement are all Graph-accessible configurations. For multinational organizations operating under GDPR or contractual data residency requirements, programmatic verification is essential. It is the difference between demonstrable compliance and assumed compliance. Continuous access evaluation adds a real-time dimension that audit trails alone can't provide, when a user's risk level changes, like a password reset or a location anomaly. CAE allows Graph to revoke active tokens immediately. You don't have to wait for the next natural expiry. Access doesn't just get logged as inappropriate after the fact. It gets terminated in the moment the risk is detected. Governance creates the foundation. Now let's talk about the operational insights that drive business decisions. Reporting, analytics, and the ROI dashboard. Most organizations measure their Microsoft 365 environment the same way they manage it. Manually, inconsistently, and only when a leader asks a question that needs an answer. A director wants to know how many active teams exist. An auditor needs license numbers. A CFO asks if the E5 investment is actually paying off. What happens next isn't a process. It's a scramble. Someone opens a portal, clicks around, exports a spreadsheet, and sends over a number that was already wrong before it even hit the inbox. That isn't reporting, that's archaeology. Graph-powered reporting changes the model. Instead of reactive data pulls, you build a continuous measurement infrastructure where scheduled queries run automatically and data flows into dashboards that refresh without you touching them. The state of your tenant isn't something you reconstruct on demand, it's something you observe in real time. License utilization is where this pays off the fastest because Graph exposes assigned licenses, active service plans, and usage signals across every single workload. When you cross-reference assigned licenses against actual product activity, a familiar pattern emerges. Somewhere between 5 and 15% of licenses in a typical tenant are assigned to accounts that show no meaningful usage at all. Shared accounts. Service accounts assigned E5 licenses for reasons nobody remembers. Former employees whose accounts were disabled but never actually deprovisioned. Each one represents a cost with zero value. Automated graph reporting surfaces this continuously, not as a one-time project, but as an ongoing operational signal. Adoption metrics add the strategic layer. License utilization tells you if a seat is occupied, but adoption metrics tell you if that seat is actually productive. You can see which workloads people are using and which teams have stopped using Teams to revert back to email. You can identify SharePoint sites that see active collaboration versus the ones that exist only as document graveyards. The Usage Reports API provides this data across Exchange, Teams, SharePoint, OneDrive, and Viva workloads. Feeding that data into Power BI gives you executive-grade visibility. You can finally see if your Microsoft 365 investment is changing how the organization works or if it's just generating invoices. The distinction between operational and strategic metrics matters here. Operational metrics, like tickets resolved or provisioning time, tell you how efficiently the IT team is running. Strategic metrics, like license ROI and governance coverage, tell you what value the business is extracting from the technology. Both matter. But most reporting stops at the operational level because that's what IT teams know how to measure. The strategic layer requires graph-powered reporting that the standard portal was never designed to provide. Baseline measurement is the prerequisite for all of it. You can't demonstrate improvement if you don't know where you started. Before you deploy a new automation, you have to measure the current state. The time per task, the error rate, and the license waste. After you deploy, you measure those same things again. That delta is your ROI case. Without the baseline, you just have a story, but with it, you have evidence. Quarterly business reviews driven by graph data do more than just justify a budget. They shift the conversation. Instead of reporting what IT did, you're reporting what the organization accomplished and where the risks still live. That's a different kind of meeting. It's the meeting where IT leaders become strategic partners instead of ticket processors. Reporting shows you what's happening. Now, we need to talk about the automation patterns that actually make change happen. Polling versus delta queries versus webhooks, the performance frontier. Most automation breaks down, not because the logic is wrong, but because the data retrieval pattern is wrong. You can write a technically correct script that destroys tenant performance at scale just by choosing the wrong synchronization model. This is the gap between automation that works in a test environment and automation that survives a production tenant with 50,000 users. Start with polling, because that's what most people build first. Polling means your script checks an endpoint on a schedule. Every hour, the script wakes up, calls the graph endpoint, retrieves the full result set, and compares it against the old state. It's simple to understand, it's simple to implement, and it's completely wrong at scale. But here's the problem. When nothing has changed, polling still runs. It still consumes your request quota and generates API traffic against the same endpoints. In a large tenant, polling scales linearly with the size of the organization. The more users and devices you have, the heavier every single poll becomes. Because polling generates constant traffic regardless of actual change, it's one of the primary triggers for graph throttling. Microsoft is very direct on this point. Continuous polling and repeated full scans are more likely to cause throttling than any other access pattern. That 429 response your automation is hitting, polling is probably the reason. Delta queries solve this inefficiency. Instead of retrieving everything every time, a delta query returns only what changed since the last sync. The first call establishes a baseline and returns a delta token. Every call after that uses the token to get back only the additions, modifications, and deletions. A tenant where 3 users change departments overnight will return 3 records, not 50,000. The request is smaller, it's faster, and it's far less likely to trigger throttling. Delta queries are available across users, groups, devices, and teams. If you're building any change tracking automation, delta queries aren't an optimization. They are the correct architecture. Webhooks and change notifications go one step further. Instead of your system asking Graph what changed, Graph tells your system the moment something happens. An event fires, your endpoint receives a notification, and your automation runs only when there's actually something to process. This is event-driven architecture. It eliminates empty work, those requests that consume quota and generate load while returning no data. In reality, webhooks require more upfront engineering. Your notification endpoint needs to be public, it needs to handle validation challenges, and it must manage retry logic for missed deliveries. Subscription renewals are a common failure point that causes these systems to silently go dark. If your webhook subscription expires and you don't renew it, Graph stops sending notifications and your automation stops responding. There is no error and no alert. You have to build subscription renewal into your monitoring from day one when you do hit throttling. And you will at some point. The only response is exponential backoff. You must respect the retry after header. Graph returns that header to tell you exactly how long to wait before you try again. If you ignore it and retry immediately, your next request counts against the same quota that just ran out. Immediate retries don't help, they make it worse. they can also create a noisy neighbor effect. This is where one team's aggressive retry behavior raises throttling pressure for everyone else sharing those service limits. Pagination discipline rounds out the performance picture. Chunking large result sets into smaller pages reduces individual response sizes and keeps each request within the limits. Small chunks might feel safer, but they actually hurt throughput at scale because they create more round trips and more overhead. You have to match your page size to your actual data and measure the results before you make any assumptions. The permission debt problem. Why Copilot deployments fail. Here is the conversation happening in boardrooms right now. An executive approves Copilot, IT spins up the licenses, users start prompting, and then something breaks. Copilot surfaces a confidential salary spreadsheet to an employee who should never have seen it. It summarizes a document from a discontinued acquisition that was never restricted. It finds content sitting in a SharePoint site from 3 years ago that still has default permissions. The deployment gets paused. The incident gets escalated. And everyone asks the same wrong question. What did Copilot do? Copilot didn't do anything. It worked exactly as it was designed to work. The problem existed long before the AI arrived. Permission debt is the accumulation of access that was granted broadly, never reviewed, and never cleaned up. It builds silently over years. Maybe a SharePoint site was created with everyone membership because it was faster than defining a proper audience. Or a Teams channel was made visible to the whole organization because the owner didn't understand the settings. Sharing links are generated and forgotten. Groups keep stale memberships from projects that ended 2 years ago. None of these felt like problems before, because humans had to know where to look. Content that was technically accessible was practically obscure. Copilot removes that obscurity. Natural language queries don't care about organizational conventions or where things are supposed to be. A user asking for a summary of executive communications doesn't need to know which library holds those files. Copilot finds them. If permissions allow it, Copilot surfaces them. The content that was technically accessible but nobody knew about it becomes instantly discoverable by anyone with a license and enough curiosity to ask. Microsoft's own security guidance is clear on this. Copilot isn't a tool that breaks security. It's a tool that reveals where your security was already broken. The oversharing was always there. Copilot just made it consequential. To fix this, you need the data access governance reports in SharePoint Advanced Management. These are the diagnostic tools for the problem. They identify sites shared with everyone, sites with broad anonymous links, and areas where permissions have drifted from your policy. Running these reports before you deploy Copilot isn't optional. It is the prerequisite. The output tells you exactly where the exposure is concentrated and where your effort should go first. For large enterprises, that cleanup usually takes 4 to 8 weeks. The technical fixes are simple, but the scope is massive and ownership is spread out. Data owners have to be found, content needs to be reclassified, access structures have to be rebuilt from a least privilege baseline rather than just patched at the edges. Graph-driven permission audits make this manageable by automating the discovery phase. They identify membership configurations and active links so your team can focus on making decisions instead of just gathering data. The contrast between organizations that do this work and those that skip it is stark. Companies with tight permissions report immediate productivity gains. Email drafting time drops. Meeting summaries arrive without prompting. Document search becomes conversational. The tool works because the data underneath it is governed. Organizations that skip the audit find themselves managing incidents instead of capturing value. And the cost of that delay compounds. Every week that permission debt stays on the books is another week where the deployment is blocked and the ROI stays hypothetical. Permission debt is a structural problem. Let's talk about the architectural patterns that prevent it. Policy as code, the operating system for enterprise governance. There is a telling difference between two types of organizations. The first has a governance policy document. It's 50 pages long. It was reviewed by legal and approved by the CISO. It sits on a SharePoint site where it gets updated once a year and read by almost nobody. The second organization has governance policies that run as code. They are versioned in a repository. They are tested in a staging environment. They are deployed through a pipeline, and they are automatically enforced from the moment they go live. Only one of those organizations actually has governance. The first has documentation. The second has infrastructure. Policy as code applies software engineering principles to your Microsoft 365 setup. Naming conventions, retention schedules, and DLP rules are no longer just settings someone clicked in a portal. They exist as scripts that declare exactly how the tenant should look. The script runs, the configuration exists, the script runs again, the configuration is validated. If someone changes a setting manually and bypasses the standard process, the next pipeline execution detects that drift. It either alerts the team or fixes the setting automatically. That drift detection is what separates policy as code from just having a few scripts. Configuration drift is one of the most ignored risks in enterprise tenants. A setting gets changed for a quick fix and never changed back. An exception is granted during an incident and becomes permanent by default. Manual drift builds up silently. The only way to find it without code is a full manual audit, which we already know takes weeks. With coded policies, drift is detected every single day. Your pipeline runs nightly and compares the actual state of the tenant against your desired state. Every deviation generates a report or an automatic correction. The tenant doesn't drift for months before someone notices. It drifts for hours before the automation catches it. CI/CD pipelines also bring something governance has always lacked: testing. When you propose a new DLP rule or a change to conditional access, the pipeline validates it in a lab before it touches your production environment. The change is reviewed and merged with the same rigor a software team uses for a code release. Policy changes that could block thousands of users no longer go straight from an admin's head into production. They go through a quality gate first. This model also gives you a deterministic rollback capability. When a policy change causes an issue, you simply revert to the previous version in the repository and run the pipeline. The previous state is restored instantly. There is no manual reconstruction. You don't have to try and remember what the setting used to be. The version history is right there. The ROI for policy as code is strongest in regulated industries, but it applies to everyone. You get fewer audit findings because your configurations are consistent and verified. You get faster remediation because fixes are deployed via pipeline instead of manual clicks. You also get audit-ready documentation as a byproduct of the process. Your repository history is the evidence trail of what changed, who approved it, and when it happened. That trail doesn't exist in a portal-managed environment unless someone logs every click, which nobody actually does. The cultural shift here is real. Treating governance like software means owning it like software. It requires version control, code reviews, and deployment discipline. For IT teams used to portal-based administration, this can feel like over-engineering. But it isn't. It is the difference between governance that holds its scale and governance that breaks the moment something goes wrong. Policy as code doesn't replace human judgment. Decisions still have to be made by people who understand the business. What it replaces is the gap between deciding something should be true and ensuring it actually is. Policy as code is the infrastructure layer. Now let's talk about the automation patterns that actually work. The idempotent principle, scripts that are safe to run repeatedly. Policy as code is your framework. But idempotency, that's the engineering discipline. It's what makes a script safe enough to run without you watching over its shoulder. The concept is simple. An idempotent script produces the exact same result whether you run it once or 100 times. The first run builds the state you want. Every run after that just confirms the state is still there. And then it exits quietly. No side effects. You don't get duplicate accounts. You don't get double license assignments. You don't see the same person added to a group twice. The script doesn't care about its own history. It only cares about what's true right now, compares that to what should be true, and only acts on the gap between the two. In Graph PowerShell, the pattern is always the same. You use getMJ before you ever touch newMake, always. You check if the user exists before you try to create them. You verify the group membership before you try to add it. You confirm the license is there before you try to grant it. If the condition is already met, you skip the action. And you log that you skipped it. If it isn't met, you take the action and you log what you did. That distinction in your logs actually matters. Already exists, skipped, and did not exist, created are two very different stories. They tell you how your pipeline is actually performing over time. This shift changes how you operate. It allows for scheduled automation without manual oversight. A provisioning script that runs every night doesn't need a human monitor, because it can't make things worse by running again. If Monday's run was a success, Tuesday's run finds everything in the right spot and finishes instantly. But if Monday's run hit a network timeout or a throttling event, Tuesday's run picks up exactly where the last one stopped. It finishes the job. The end state is correct, regardless of how many times the connection dropped. Error handling here requires a specific kind of discipline. You have to distinguish between this was already done and this failed. At the code level, they look similar. Neither one results in a new action, but operationally, they are opposites. An account that already exists is a win. An account creation that threw a 403 error is a failure that needs a human to look at it. If you collapse these into a single skip path, you're just hiding real failures inside expected behavior. Then there's partial failure handling. If you're processing 1,000 users and user 400 fails because of a missing attribute, the script shouldn't stop. It should log the error, move to user 401, and finish the run. At the end, your failure log tells you exactly which records need a fix. The 999 users who succeeded shouldn't have to wait for the one who didn't. Finally, you need safety limits. If a script does something destructive, like deleting accounts or pulling licenses, it needs a hard cap on how much it can change in one go. A script designed to disable inactive accounts should never hit more than a small percentage of your users in a single run. It doesn't matter what the query says. That limit is there to catch logic errors. It catches the filter mistake that makes everyone look inactive. The cap doesn't stop your automation, it stops an automation disaster. Idempotency is a discipline. Now let's look at where this actually pays off in the real world. Automation that delivers ROI. 3 case studies. Theory is fine, but numbers are better. Let's look at 3 organizations that built their automation on Graph and measured the impact. First, a global manufacturer with 20,000 factory tablets. Before they used automation, every single device needed a manual setup, a technician, a ticket, a physical checklist. At that scale, managing devices wasn't an IT job. It was a massive logistics nightmare. They moved to zero-touch enrollment using Intune and the Graph API. They used PowerShell scripts to handle the configuration, the apps, and the compliance reports. Not a single person had to touch the devices. The results were massive. 90% of their management tasks are now fully automated. They reclaimed 15,000 hours of labor every year. That's time that used to vanish into manual setups and troubleshooting. Vulnerabilities dropped by 65% because the scripts didn't forget to patch things like humans do. And audit prep? That went from 3 weeks of stress down to 2 days of clicking buttons. The evidence collection was just a scheduled script. The difference wasn't the tools, it was treating device management as a programmable system instead of a list of chores. The scripts were idempotent. The pipelines were versioned. The outcomes were measured. That's why the numbers actually held up. The second case is a financial firm with a problem most of you probably have: orphaned licenses. They had licenses sitting on accounts that hadn't been touched in months. Service accounts were holding E5s for no reason. People changed roles but kept their old, expensive licenses. At their scale, this waste was invisible to a manual review. They built a graph-driven optimization script. It cross-referenced assigned licenses against actual usage signals from the reporting API. If an account had no logins and no activity for 90 days, it got flagged. Owners got a notification. Licenses were reclaimed after a review period. And because the script kept running, the waste couldn't pile up again in secret. The outcome was a reclaimed license spend of about 15%. For an enterprise with thousands of seats, that is 6-figure savings every single year. The automation paid for itself in less than 12 months. The scripts weren't even that complex. The problem was just widespread, and the solution never stopped running. The third case is an insurance company that wanted to roll out Copilot, but they did something smart before they assigned a single license. They ran a data readiness audit. For 4 weeks, they used Graph to audit permissions across SharePoint and OneDrive. They generated governance reports to find sites with everyone access. They mapped out external sharing links and sensitivity labels. The audit didn't just find problems, it quantified them. It let them prioritize the cleanup based on actual business risk instead of a gut feeling. The cleanup took another 4 weeks. They restructured the messy sites. They applied labels to content that had been sitting unclassified for years. They revoked the old sharing links. Only after the house was clean did the Copilot licenses go out. The result was a rollout that actually worked. Users saw a 30% drop in the time they spent drafting emails and summaries. And because they took a baseline measurement before they started. The ROI was a fact, not a guess. They had something most Copilot adopters are missing. They had evidence: 3 industries, 3 different problems. But the pattern is the same: automation built on Graph. Measured from day one and scaled because the foundation was solid. These aren't what-if scenarios. They are happening right now. So let's talk about where we go from here. The Copilot connection, how Graph powers AI agents. Copilot isn't a chatbot. It isn't some separate tool bolted onto Microsoft 365. It's an orchestration layer built directly on top of Graph. That means everything we've talked about, permissions, lifecycle, governance, determines whether Copilot works well or fails completely. The architecture is simple but critical. When you submit a prompt, Copilot doesn't look at a private AI database. It calls Graph. It queries the semantic index built from your emails, your files, and your team's messages. It finds the right content, and then it applies security trimming. It checks your actual Graph permissions before the AI ever sees the data. The model never sees a file you aren't allowed to access, because the enforcement happens at the Graph layer. But this creates 2 problems. First, Copilot is only as smart as your data. If your information is messy, fragmented, or labeled wrong, the AI will reflect that: garbage in, garbage out. Second, and this is the part most people miss, Copilot is only as safe as your current permissions. There is no separate security layer for AI. There are no Copilot permissions. It simply inherits what you've already built. If you did the work to clean up your permissions before you deployed, you see the benefit immediately. Relevant files surface. Confidential data stays hidden. The tool earns trust because it behaves exactly how you expect it to. But if you skipped the governance work, you usually find out through an uncomfortable incident. Sensitivity labels and DLP policies are the only things keeping the AI in check. If a document is labeled confidential in Purview, Copilot won't show it to someone without the right access tier. These aren't special AI settings. They are the same controls you use for everything else. And that's the point. Governance built for one purpose covers every purpose. Graph connectors extend this even further. Your knowledge doesn't just live in Microsoft 365. It's in ServiceNow, Salesforce, and SAP. Connectors pull that external data into the semantic index, making it available to the AI. But if your connector permissions are wrong, you've just created a fast lane for data leaks. The model is shifting. Copilot agents are now being registered as first-class objects in Entra. They have identities. They have permissions. You govern them through Graph just like a service principal. The work you do today on permission hygiene isn't just prep work for the future. It is the prerequisite for the AI you're trying to use right now. The work isn't ahead of you. It's what's blocking you. Copilot is the present. Now let's talk about the agentic future. Agent 365 and the agentic future, autonomous systems on Graph. The governance conversation is about to get complicated, not because the rules are changing, but because the actors are. Right now, you have two types of entities in your tenant, humans and applications. Humans log in and do work. Applications run as service principals and follow a script. You manage both through Entra ID and the Graph API. It's a mature model, but now we're adding a third category, autonomous agents. These aren't apps that follow a fixed path. Agents get a goal and they plan the steps to reach it. If you ask an agent to write a board report, it doesn't just run a script, it decides which data to gather. It queries Graph for files. It identifies gaps and asks for more info. It does all of this without a human directing every single click. Microsoft is building the infrastructure to control this. Agent 365 moves agent management into one single control plane. It gives you the same visibility over agents that you have over service principals today. Agents are registered in your directory. They have identities and they have scopes. They show up in your audit logs. You can put them in groups and define exactly what they are authorized to do. The registry Graph APIs for this are moving fast. They were in preview in early 2026, with full release targeted for June 2026. This allows you to onboard agents at scale. You can inventory every agent running in your tenant and feed that data into your risk reports. Underneath it all is the Model Context Protocol, or MCP. This is the layer that standardizes how agents talk to tools. When these servers are governed through Graph, Graph becomes the enforcement point. It decides which tools an agent can use and which data sources it can touch. One agent calling another agent to finish a task isn't a theory anymore. It's on the roadmap. The only question is whether your tenant is ready to control it. For architects, this means Graph PowerShell is becoming your DevOps surface for AI, registering agents, managing their lifecycle, auditing their work. It all runs through Graph. If you already have a foundation in policy as code, you'll absorb this easily. If you don't, you're going to have a new category of ungoverned actors running wild in your system. The scale is the challenge. Agents aren't that different from service principals. They still need least privilege. They still need regular reviews. They still need clear owners. The only thing that changes is the volume and the speed. The organizations that master Graph governance now are building the only safe way to use AI. The discipline isn't separate from the future. It's the only way to get there. Agents are a fundamental shift in how we work. Let's talk about what that means for your career. The skills gap. Portal-only admins versus Graph architects. In February of 2026, the Microsoft 365 Admin Center went dark for several hours. It was a quiet watershed moment. For most IT teams, the portal is the only way they know how to work. When the interface disappeared, their daily operations stopped. They couldn't manage licenses. They couldn't provision users. They were locked out of their own environment. But for organizations with mature Graph and PowerShell practices, it was just an inconvenience. They kept working. They managed security events and handled user requests through the same API surface they use every day. While the rest of the world was waiting for a website to load, these teams didn't miss a beat. This incident exposed a reality that is becoming more decisive every day. The portal is just a rendering layer. The real control plane is Graph. If you only know the portal, you are structurally dependent on what Microsoft chooses to show you. You're limited by their interface, their feature sets, and their data visibility. And as we saw in 2026, you're dependent on their uptime. The gap between a portal admin and a Graph architect isn't just about technical skill. It's about leverage portal admins implement what the interface allows. Graph architects see the entire data model. They don't just close tickets. They design programmatic infrastructure that enforces policy automatically. These aren't the same job with different titles. They are different roles with completely different career trajectories. By 2027, this gap will define who gets hired and who gets left behind. We're already seeing organizations form dedicated automation teams. These are small groups of Graph-literate engineers who build the systems that replace manual work at scale. 5 years ago, these roles barely existed in mid-sized companies. Now, they are standard operating procedure for anyone serious about Copilot deployment or large-scale identity governance. The market is paying a premium for this because the math is simple. One architect building policy as code can do the work of several manual admins. More importantly, they can provide capabilities that a manual team couldn't deliver, regardless of how many people you hired. So what does it actually take to become Graph literate? The learning curve is steeper than clicking buttons in a portal, but it's not as high as people think. You can learn the fundamentals in a few weeks of focused practice. You need to understand the data model, how to navigate permissions, and how to call endpoints. Microsoft makes this accessible. You can go to the Graph Explorer right now and run live queries against your own tenant without writing a single line of code. The documentation is clear. The Graph PowerShell SDK handles the heavy lifting of the raw mechanics while keeping you close enough to the model to understand what's happening. Mastery takes longer, of course. There is a big difference between calling an endpoint and knowing how to chain them together for a complex workflow. You have to learn how to write scripts that run safely in production and how to avoid throttling events that can ripple across your entire tenant. You only get that depth by building real things. Organizations that invest in this training now are buying more than just a technical edge. They are building institutional knowledge of how their systems actually connect. They aren't looking at a UI. They are looking at the source of truth. That knowledge compounds over time. If your team builds graph fluency this year, they will be ready to govern AI agents next year. The patterns are the same. The logic transfers directly. The admins who wait aren't just standing still. They are falling behind a curve that is accelerating. More and more critical capabilities are surfacing exclusively through graph, leaving the portal behind. Skills matter because the future is being built right now. And that brings us to the deadlines you can't afford to ignore. The ticking clock, critical deadlines and forced migrations. The strategic reasons to move to graph are clear, but there is a much more urgent reason to act. It has nothing to do with your career or your competitive advantage. Microsoft has set hard deadlines that will break your environment if you miss them. Not degrade your performance, not create an inconvenience. They will break your tools. The first major deadline has already passed. On June 30th, 2025, Azure AD Graph was officially retired. This wasn't a soft retirement where the documentation just stops getting updates. It was a hard cutoff where API calls stopped functioning entirely. If you had an application or a script built on the old system that didn't migrate to Microsoft Graph by that date, it died. Microsoft even ran planned outage tests throughout the summer of 2025 to help teams find hidden dependencies. Those tests were a warning. The permanent shutdown was not. The legacy PowerShell modules followed the same path. Azure AD and MS Online were deprecated back in March of 2024. They only kept working because of a back-end grace period that ended when the API itself was retired. If you are still trying to run provisioning scripts against those modules today, you aren't on borrowed time. You're running on nothing. The next big hit is the Graph CLI, which retires on August 28th, 2026. This one is going to catch a lot of people off guard. The Graph CLI felt like the modern choice. It used current auth patterns and it called the Graph API. It seemed like the right direction to go. But Microsoft has decided that the official target is the PowerShell SDK. The retirement for the CLI is hard. There is no extended access. If your automation relies on it, you have until August of 2026 to move, and there is no room for negotiation. Then comes December 31st, 2026. This is the date for the mail advanced permissions change. Right now, the standard mail read-write permission lets apps update a lot of different message properties. After the end of 2026, that changes. If an app needs to update sensitive fields like the subject line, the body, or the recipients, it will require the new Mail Advanced permission family. That family requires mandatory admin consent. Applications that try to modify email properties without that explicit permission will simply stop working. They won't give you a helpful warning. They will just throw 403 errors that could take your team days to diagnose if you aren't prepared for the shift. We're also seeing a broader secure by default move in mid-2026. Microsoft is shifting the default policy so that many exchange-related permissions will require admin consent by default. If you have apps that relied on users consenting for themselves, those apps will break the moment the policy flips. The pattern here is always the same. Microsoft makes an announcement. Organizations take a note of it. Then the deadline arrives and the emergency scramble begins. The teams that treated these dates as planning inputs are fine. The teams that treated them as problems for later are now rebuilding their entire integration stack under extreme pressure. These are not optional upgrades. The platform is moving forward and it is dropping backward compatibility at very specific points in time. The calendar is public. The only variable is whether or not you are ready when the date arrives. Deadlines create urgency. So let's talk about how you actually build a real graph strategy. Building your graph strategy, the roadmap. Strategy without a sequence is just intention. Organizations that actually close the gap move through a specific order. They don't just do automation. They build it. Phase 1 is discovery and baseline. This takes 2 weeks if you move with purpose. The goal isn't to fix anything yet. It's to see clearly. You need to find the friction. What processes in your environment are still manual? Where are humans clicking through portals to do work that a script could do in seconds? Map it, quantify it, calculate the time per task and the frequency per month. That arithmetic tells you where automation delivers the fastest return, and it prevents you from wasting time on edge cases that don't matter. Simultaneously, you need to run permission discovery. Use Graph to see who actually has access. Enumerate which sites have broad membership and which service principals hold permissions that haven't been used in 90 days. Look for app registrations that have accumulated scopes well beyond their original purpose. You're not remediating yet, you're establishing the before state. This baseline turns future improvements from stories into evidence. Organizations that skip this step end up unable to prove ROI later because they have no reference point for comparison. Phase 2 is the pilot running from week 3 through week 8. The selection criteria for your first project matter more than the technical complexity. You want something high impact, low risk, and measurable. License reporting is a reliable starting point. It touches almost no write operations, produces immediate value, and gives your team hands-on experience with the graph reporting API before you're dealing with production accounts. User provisioning for a specific department is another strong candidate. It has a bounded scope, clear success criteria, and a stakeholder who will actually notice the improvement. Build it idempotently from day one. This isn't the best practice to apply later. It's the structural constraint that shapes every script you write from this point forward. Measure the performance before you deploy. Track the time per task and the error rate from manual processes. Calculate the cost of license waste before the cleanup runs. 2 weeks after deployment, measure those same things again. Document the delta. That documentation is your case for more investment. It's the institutional memory that justifies the next phase when the budget conversation comes. Phase 3 is the governance framework, covering weeks 9 through 16. This is where the work becomes infrastructure rather than just a series of projects. Naming conventions get codified, retention schedules get scripted, DLP policies get versioned, the permission review cadence gets formalized. You move to monthly reviews for high-risk applications and quarterly reviews for routine governance. These reviews run as automated reports rather than manual audits. Build dashboards that pull graph data on a schedule. Surface the metrics that matter to different audiences. The CISO wants to know about security posture, the CFO wants to know about license efficiency, and the CIO wants to see adoption curves. This is also when you establish your CI/CD pipeline for configuration changes. Any policy modification must go through review and testing before it touches production. This discipline protects you from the category of incident that's hardest to explain to leadership, an IT-generated outage caused by a change that wasn't validated. Phase 4 has no end date. It's the ongoing operating model. Expand automation as your team's graph fluency deepens. Monitor throttling metrics to catch performance patterns before they become operational problems. Build feedback loops between your automation outcomes and the policies that drive them. When a new Microsoft 365 capability launches, the platform moves fast enough that something significant lands every quarter. Your team's first question should be which graph endpoints expose it and what automation patterns it enables. The realistic timeline for a mature infrastructure is 6 to 12 months. It takes that long not because the pieces are complex, but because building organizational discipline around code review and monitoring takes time. Start the clock now. Every week that passes before the first script runs is a week that doesn't count toward your progress. Authentication patterns, certificates, managed identities, and secrets. Authentication is where security intentions meet engineering reality. The permission model defines what an application can do. Authentication determines whether the application can prove it's authorized to do it. Getting this wrong doesn't just create a security gap, it creates a gap that looks closed until a credential is compromised. At that point, the blast radius is determined by how broadly that credential was trusted. Client secrets are where most teams start because they're simple. You generate a value, store it, and pass it in the request. That simplicity is exactly the problem. A client secret is just a password. It has the same failure modes as any password. It can be committed to a repository, logged in a pipeline, or stored in a config file with bad access controls. Secrets expire. This creates pressure to extend their lifetime rather than rotating them properly. When a secret is compromised, the exposure window extends all the way back to the last rotation, not just to when the breach happened. The rotation discipline required to make secrets safe is operationally heavy. Most organizations don't maintain it. Secrets quietly accumulate long lifetimes. The ones that should expire in 90 days get extended to a year. The ones that should have been rotated after a personnel change weren't because nobody owns the process. Azure Key Vault is mandatory if you use client secrets. It provides rotation policies and audit logs that make the exposure window visible. But Key Vault doesn't eliminate the fundamental weakness, it just manages it. Certificates raise the bar significantly. Certificate-based authentication replaces the shared secret with an asymmetric key pair. Your automation holds the private key, and Microsoft validates the public key registered against your application. The private key never leaves your environment. It can't be guessed or brute forced through the API. Certificate rotation is more complex than secret rotation, but the security improvement justifies the effort. If your provisioning scripts or governance workflows run with user, read-write all or broader, certificates are the minimum acceptable pattern. Managed identities are the right answer for automation running inside Azure. When your runbook or function runs in Azure, it can assume an identity assigned to the resource. There are no credentials to manage, no secrets to rotate, and no certificates to track. The identity is tied to the Azure resource itself. When the resource is decommissioned, the identity goes with it. You can't accidentally leave a managed identity active after the workload it served is retired. For graph automation running in Azure Automation or functions, managed identities should be the default choice. Using a client secret should require documented justification. Understanding the OAuth 2.0 flow matters because the flow determines what the token represents. The client credentials flow produces a token that acts with the full scope of the application's permissions. The authorization code flow produces tokens scoped to a specific user's rights. Continuous access evaluation means Graph can revoke tokens in real time when risk signals change. If a user account is disabled or a location anomaly is detected, the access stops. Shorter token lifetimes reduce the window between a risk event and access termination. The default 1-hour lifetime is a balance between performance and security, not an optimization target. The summary is direct. Use certificates or managed identities for production. Use secrets only with Key Vault and strict rotation policies. Keep token lifetimes short for anything touching sensitive scopes. Operational excellence, monitoring, alerting, and incident response. Authentication holds the door. Governance defines the rules. But neither matters if nobody is watching what happens once your automation is running in production. Operational excellence in graph-driven environments starts with a question most teams never ask until something breaks. What is your automation actually doing right now? Not what it's supposed to do, not what it did last week during testing. What is it doing at this moment against your live tenant? Graph activity logs reached general availability in April of 2024, and they answer that question with a precision that simply didn't exist before. Every HTTP request made to Microsoft Graph by every application in your tenant gets recorded. The endpoint called, the identity that called it, the response code returned, the timestamp. That log stream is the diagnostic layer underneath your entire automation stack. The immediate operational use is throttling detection. When your scripts start hitting 429 responses, the activity logs show you exactly which application is generating the load, which endpoints it's hammering, and at what frequency. You can see the noisy neighbor problem before it escalates from degraded performance to failed operations. Because you have this data, you can adjust chunk sizes, introduce batching, or spread workload across different execution windows based on actual telemetry rather than speculation. Audit logs serve a different but equally critical function. Where activity logs tell you what applications did, audit logs tell you what administrators and users did, who changed a conditional access policy and when. Which account added an application permission that wasn't in the approved baseline? Which admin removed a user from a privileged role at 2 a.m. on a Sunday? This is the evidence trail that governance frameworks depend on, and it's the data that incident response teams reach for first when something goes wrong. Feeding audit logs into a CM, like Microsoft Sentinel, creates the correlation capability that turns individual events into patterns. A single unusual permission grant is noise. 3 unusual permission grants from the same source in the same hour is a signal that deserves attention immediately. Alerting needs to be specific to be useful. Generic something happened alerts produce alert fatigue and train teams to ignore the notification system. Effective alerting is targeted. Bulk deletions above a defined threshold, new admin consent grants outside business hours. Service principals gaining permissions that weren't part of their registered baseline. Sign-ins from accounts that should be service only. These conditions are buildable as graph-backed detection rules. The logic runs on a schedule, compares current state against expected state, and fires only when the deviation is real. Error tracking inside your automation deserves the same rigor as error tracking in any production software system. Transient failures, like a 503 from a briefly unavailable endpoint or a timeout during a large query, are expected and recoverable with proper retry logic. Persistent failures are different. Repeated 403s indicating a permission change or consistent 400s indicating a malformed request after an API update are signals that something structural needs attention. A logging pattern that distinguishes these two categories turns your error stream from noise into an operational dashboard. You see which workflows are running cleanly, which ones need a retry policy adjustment, and which ones need a human to investigate why they're consistently failing. Runbooks give your team a structured response when incidents do occur. Not every alert needs an investigation from first principles. A documented runbook for common scenarios, like throttling events, certificate expiry warnings, or permission drift detections, means the on-call team follows a proven process rather than improvising under pressure at 3 a.m. Blameless postmortems close the loop. When something fails in production, the conversation should end with updated runbooks, improved alerting thresholds, and better test coverage for the failure mode that surfaced. It shouldn't end with someone being held responsible for a gap the process itself should have caught. Operations keep systems running. Now let's talk about the future state. The future of M365 administration 2027 and beyond. Picture the role of M365 administrator in 2027, not as it exists today, reactive ticket-driven .portal dependent, but as it's being actively redefined by the organizations already operating at the frontier of what Graph makes possible. The portal doesn't disappear. It persists as the interface for simple, occasional tasks, like checking a setting, verifying a configuration, or investigating a specific account during an incident. But serious work happens at the API layer, the work that shapes how an organization operates. Configuration is declared in code and deployed through pipelines. Governance is enforced by automation and validated continuously. Security posture is monitored by systems that alert on deviations rather than humans who notice them eventually. This isn't a prediction. It's a description of infrastructure already in production at organizations that started 3 or 4 years ago and have been compounding that advantage since. The question isn't whether this future arrives, it's whether your organization is building toward it or inheriting the gap when it does. AI and agents will be the primary consumers of tenant data within that timeline, not users browsing document libraries, not admins running reports, but autonomous systems making thousands of graph calls per hour to ground decisions, execute workflows, and coordinate across services. The governance implications of that shift dwarf anything we currently associate with application permission management. Your tenant will be interacting with systems that act faster than any human-led review process can track, which means the controls have to be structural rather than procedural. Policy as code isn't a modernization project for 2027. It's the baseline expectation for any organization that wants to deploy AI agents without creating ungovernable risk. The shift in how administration gets valued reflects this. Systems thinking becomes the core competency that separates architects from operators. The ability to reason about how identity, permissions, data flows, and automation patterns interact at scale. Knowing which portal blade contains which setting has diminishing value as more of those settings get managed programmatically. Understanding the data model underneath the portal, the permission boundaries that constrain what automation can reach, and the performance patterns that determine whether large-scale operations succeed or throttle. That knowledge compounds in a way that GUI familiarity never could. Automation stops being exceptional and becomes the expected baseline. The question organizations ask about any repeatable administrative process won't be, should we automate this? It'll be, why hasn't this been automated yet? The organizations that build idempotent, versioned, monitored automation infrastructure over the next 18 months are the ones positioned to answer that question confidently. The ones that waited are rebuilding under pressure while simultaneously trying to govern AI systems they didn't plan for. Security and compliance enforcement follows the same trajectory. Manual policy reviews get replaced by continuous drift detection. Audit preparation gets replaced by always-on evidence collection. Incident response gets faster because graph activity logs make the timeline of what happened reconstructible in hours rather than days. The competitive advantage isn't permanent for those who move early. Eventually, these practices become table stakes, but the organizations that master them first build institutional knowledge that can't be purchased off the shelf or caught up to quickly. The window to build that advantage is open right now. The future is clear. Now let's talk about what you should do starting today. Your first steps, the roadmap, the case studies, the deadlines. None of it matters until someone on your team opens a terminal. You need to run a query against your actual tenant. That first step is smaller than you think, and it's where the shift begins. Start with an honest audit of your current state. Not a strategy meeting, a literal inventory. Open a spreadsheet if you have to. List every recurring task your team does manually. Write down how long it takes, how often it happens, and if any automation exists at all. Most teams find the same thing. The majority of their time goes to tasks that are fully automatable. And the automation they do have, it was built ad hoc. It isn't monitored, and it wasn't designed to be reliable. That inventory is your starting point. It shows you where the leverage is before you write a single line of code. While you're auditing processes, audit your permissions. Run a query to find service principals with permissions they haven't used in 90 days. Pull a list of SharePoint sites with broad membership. Check which app registrations have accumulated scopes they don't actually need. You already know what permission debt costs when you deploy Copilot. Seeing the scope of your own debt is motivating. The abstract argument becomes a concrete problem. Step 2 is learning the fundamentals. The entry point is easier than the documentation makes it look. Go to graph.microsoft.com and open the Graph Explorer. It lets you run queries against your live tenant with zero local setup. Start there. Type get users and look at the response. Add a select statement for display names and mail to see how it reduces the data load. Run a query for groups and filter by name. These aren't production scripts, they're conversations with the data model. 10 minutes of exploration teaches you more about the graph schema than an hour of reading. From there, move to the PowerShell SDK in a test environment, connect with your own account, retrieve something, modify something that isn't critical. See what a throttling response looks like before you hit one in production. Understand what the response body tells you about when to try again. This isn't about mastery yet, it's about orientation. And orientation is what makes the first real project move faster. Step 3 is picking that first project. The criteria matter more than the technical difficulty. You want high visibility with a low blast radius. License reporting is the classic entry point. There are no write operations. It provides immediate value. And stakeholders will actually notice. User provisioning for a single department is the next level. Build it to be idempotent. Measure the state of things before you deploy. Measure it again 2 weeks later. Document the difference. Step 4 is sharing what you find. Show a dashboard of recovered licenses. Compare provisioning times before and after the change. These aren't just metrics. They're the argument for the next phase of investment. Results become budget justifications. Budget justifications become dedicated automation teams. And those teams build the infrastructure Graph needs to reach its full potential. Step 5 is the calendar. If Azure AD Graph is still in your environment, That's the emergency. The Graph CLI retires in August of 2026. Mail permission changes land in December of 2026. Put those dates in your tracker right now. Do it before this section closes. Do it before the episode ends. Start small. Measure everything. Scale what works. The portal is just a convenience layer. Graph is your control plane. PowerShell is the engine that makes it work at enterprise scale. Everything we talked about today, user lifecycles, governance, security, and copilot readiness, it all runs through that same foundation. The companies building on it right now aren't waiting to see what happens. They are building an advantage that gets harder to beat every single month. But here's the problem. The deadlines are real, the skills gap is real, and the permission debt sitting in your tenant right now is very real. None of it gets easier by waiting. So what is actually happening is a shift in how we work. Start with one audit. Pick one pilot project, measure what changes. Every serious graph program started the same way. It didn't start with a big initiative. It started with one person running a query and seeing data the portal never showed them. If this changed how you think about M365, follow me, Mirko Peters, on LinkedIn, leave a review for the podcast. It helps more people find it. And share your biggest challenge with Graph in the comments. I read everyone.